So in the last class I wrote lots of code where I use multiple library such as NumPy and Matplotlib. Some important function of scalar I use in my last class. And you see I have created our own model with the Python, and this is their code. In the last class, just one second. Okay. In the last class, I use uh, this cell to writing the logistic regression code in the Scratch Python, and I have created multiple functions. Some function is easy to understandable, some function is difficult to understand, such as this function. This function is nothing. This function just will connect my vocal that I can write something, and you can get what is happening on the code. So guys, I will ask some question to you and you have to give me the answer. Okay, because that's why if you give me the answer, it is easy to understand for me that you are understanding everything in this one. Just one second. Let me. Where is my pen? No. Okay. Now. So first, tell me why we use logistic regression. Okay, what is the role of logistic regression in machine learning? Anyone in this classroom who is able to give the answer of this question? Anyone? Why we use logistic regression? Guys, I am giving the answer of this question. In the in few few days back, you have learned some types of machine learning, where you see the two types of machine learning. One machine learning is supervised, one machine learning is unsupervised. In a supervised, there is another two types of machine learning is possible. One is classification and another one is regression. Regression generally used for getting the some distinct value or some continuous value, and in the classification generally used for classify the data, such as that the number the person is going to pass the exam or not pass the exam, or a person is going to be leave in 2024 or not, or maybe this type of person means this type of things is under the classification. And you know I'm using two model in my first model is linear regression. Linear regression is generally used for regression machine learning, and logistic regression is generally used for classification. Why I am using logistic regression? Because in the case of logistic regression, output is either 0 or 1. Basically the value is going between 0 to 1. By using the probability, I will convert to 0 to 1. Suppose sometime you will get the value 0.85. So you can see that 80% chance this is the positive value, and you will convert to value to 1. If you are getting the value 0.35, so you will convert to value 0 by using the probability. So you can use this logistic regression to make the classification. And in this classroom, you see I have a data set like this. This is a some point is red, some point is green. Okay, and I want to classify this data set. Okay, and I am going to use some linear regression. So linear regression will help me to find the classification for this data set, and I am using this, I am creating this model and all. So you know how the logistic regression model work. It is very need to be understand. This logistic regression equation looks like this. In the first class, I am using this graph, and I am using this graph everywhere. This graph is, this node is tail, this is input and this is the output. Okay, and this is your function you are getting, and you come with a new input and you will get the prediction, and here you choose the model how the function is looks like. So suppose you will decided your function is looks like this. This function is looks like this, means only thing you have to find the value of a and b and the function will complete. Same as for the logistic regression, the function is looks like this. Only thing you have to find the value of a and b, because e is fixed. E's value is like 3.71, I guess. So here e is fixed, x is fixed, x is a variable term, and you have to find the value of a and b. And in the very past class I have already explained how to get the value of a and b by using the gradient descent algorithm. So you get the value of a and b by using this graph and all, like this is equation graph of, this is a error graph, and this is the value of a and b, and you will get starting value is 1, and you will changing the value and see how your value, error value is decreasing. After a certain number of epoch, your value will be getting decreases, and you fix that this a and b should be better for this model, and you will complete the equation, and you come with a new input, like you need only one value of x and you get the value of y. Is this clear, everyone? There is any issue to understand the logistic regression? Say yes or no at least. If you are facing some difficulty to understand, please let me know, I will repeat it again. Now, so come to this word. Here, this is perceptron. This perceptron returns this value. Okay, and this sigmoid function returns this equation. See, this and this. And now the gradient descent is what? In the last class I have derived this equation. Maybe this derivation is stored in my OneNote. Let me check. Okay, so in the last class I have tried to get the value of this. So basically in the gradient descent formula, what is happening? You will get some error equation which is like y minus y predict ka whole square, something like that. It is going from I to n, and you need to be find delta w, because this is change in w, for getting the value of new w. So this is the way that you have to get. So this is the equation, you dw and you find the equation. Okay, you will get the equation and so on. At the end, after the derivation, your equation looks like this. Okay, I have already explained this equation in my previous classes, so maybe in the recording lecture you will get this equation. And you see, this equation is nothing, this equation is this. And for the same for the gradient b, you will get this equation. Is this clear? Because I already explained in my previous classes. And now the next, this is the gradient descent algorithm under the fit function. So first, same, you have to use the same approach you have learned in the theoretical part. That this is your, so this is your error function, and this is your a and b. You use some random value of a or maybe b. So this first two lines explain that, some random value. This is another thing, we are going to store every loss in this array. Next, I am using tcodium because I want to see progress in my console. Only for that thing I am using this tcodium notebook. Otherwise, it is similar to for loop. So you can ignore this. You can further understand. So now this is the dw and this is a db, change in w and change in db, because your error is summation of y minus yi का whole square. This is prediction and this is I. So that's why I am using dw, and you are starting the summation by using this for loop. And every time I am adding the value of dw and db, because there are lots of small delta w and small delta b is getting yi y1 and y prediction 1 का whole square and this. So here we get delta d1 and d2 and so on. So by this equation you are getting to be total dw. And after same algorithm in gradient descent you are using, every epoch you have to update. I'm using a and b, you have to use w and p. This is w. So every time you have updating the value of a and b, and learning rate is a small number, you have to multiply with that to slow decrease or fast decrease. So you will get new w and you checking for this. Again you have to get the new w and checking for this. Now suppose you are getting here after this first epoch, you will get w and b, some w and b. And now for this w and b, you will check what is the possible output for every input. What is the possible output for every input, and you store the error, total error. You store this total error in this ls variable, and ls variable is append to this loss list. Okay, nothing I am doing it here. Now this is the way you have training is completed. So guys, I try to explain everything. If you are facing any error, please let me know till this point. Please say yes or no. If you are saying no, if you are facing any error, if you like have some difficulty to understand, please let me know. Otherwise, I will just explain the other parts. Okay. Mean square error is a function. Mean square error is a function. This is simple function. Same as like factorial function. This is a function. This function has the mean square is function. It is returning y prediction minus square, and they are using this part. I am ignoring this square error, mean square error. If you are little bit confused that why I am using mean square, you can also use square error, but already have some function, that's why you can also use this part, mean square error. This is the function. So actually you have to calculate the total error in two ways: absolute error, a square error, mean square error. Oh, sorry, not mean square. This is the mean square means y minus y prediction का whole square by total number of input. So this is the function written this. Clear? Hello? Clear everyone? She is asking, actually let me, oh self, oh sorry, just 1 second. Actually when you create any function, and if the function you are going to be attached to this class, so you have to be used as a argument as a self. It is similar to this for another programming language. Okay, so it's a simple thing. If you are using Python, or you are using creating a variable or or some class variable or class function, so you have to use a one argument self. Okay, this is a Python thing. Clear? Okay. let me explain this. I don't want to be uh, jump into this again, but let me explain this. So basically what is happening here, so you listen. So basically, so we have an equation like E and suppose like W and B. So it is what? E is what? If you are talking about this point like X and you are, this is your real value, and by using this graph you are getting this value. This is your prediction value. So this is your difference, is your loss, and you know how you get the difference. So suppose I am using J for the in place of E, and it is what? It is Y minus Y prediction, and because I want to decrease the negativity, so I am using the square term. Okay, and this is the summation for every point. Okay, so your J should be looks like Y minus, and Y prediction is a function. So this function is का whole square. Suppose we have only one point, so we can go with this equation. Suppose there is only one point here, n is equal to 1. So this is the only thing we are getting, and you know your you are going to get this value at some number of epoch, this W and B. So you have to randomly choose a W and B, and you are updating the value of W. The screen is not visual, only logistic regression. Okay. Okay. Sorry. Don't worry, this thing is recording on the good thing. Now it's visible. Every screen, everything you are getting right now. Yes. So now let me explain it again. So you are understanding this graph. This is your equation graph, and this equation is coming from this, means actual value and real value difference, and you are getting to be square, adding all the difference in a square format, and you can see this is a J. Suppose we have only one input, n is equal to 1, so you will get this value only till this point. This is clear. This is a total error, and I using J. Clear? This part is clear. This is a equation of error. Yes or no? Okay, now. So I am using Y minus square error. So now we need to update the value from in change in W, a small change in W, because in this graph you have to small change, and you know a small change means what? DW. So how we get this DW? So suppose I am derive this by the partial derivative delta G by dW like this. So you can derive this, and you know, if you already know about some calculus part, so you know about some chain rule, and even in this class you don't know what the meaning of chain rule. In the differential calculus there is something is chain rule, where you can differentiate this type of equation very easily by using the chain rule. Everyone know about the chain rule? Hello? Yeah, good. So in this chain rule, So because this is a totally different thing, the W is not available. You have to be differentiate the entire part by this. So you will get 2 comes first, and you will get y minus this part. Okay, and you will get again, you have to differentiate this part by dw. Now again, this is y minus y prediction, and now you have to differentiate it. So this is a constant term, so dy by dw is 0, and now you are getting this. So you are getting this means you have to differentiate this to getting follow again the chain rule. So we are going to be 1 plus e the power wx plus b. So I will change to this. So it will be like negative of 1, yes or no, and by dw. So again we are getting 2y into y prediction. So you multiply with this is 0 and then multiply with this, and now you have to differentiate with this. So you have to differentiate with 1 plus this by 1 plus dw. Now if this differentiation negative 1 comes first, and you will get negative 1 minus 1, so it will be like minus 2. So it will be like 1 by b का whole square, and you are again differentiate this. So this is a constant term, so you have to again differentiate with the again chain rule. So you will get and you have to differentiate this, so you are getting negative s. Okay, I think everything is differentiated. Everything is differentiated till this point. So maybe I will. So just 1 second, let me check this. I'll differentiate in multiple times. So this is yp the whole square. Sorry, not yp. This is yp the whole square. And this is and this is so I will add plus 1 and minus 1, and negative negative cancel each other, and it is supposed to be x. y minus yp. तुम लोग क्या करवा रहे हो? मैथमेटिक्स करवा रहे हो जैसे. ओके. And yp and so on. So this is yp whole square. Guys, if I getting any wrong, please you can help me on that matter. And it is supposed to be 1 by this. Okay. And I think I am doing right. Maybe there's some negative will be, and this is y. Just 1 second. Just 1 second. Just 1 second. Okay. Sorry, y prediction. Okay, and last, yeah, it is completed. Y minus yp and yp square, and this is, sorry, and this is yp square, and this is 1 minus yp, the x, and this is yp, and this square is cancel each other, and you are getting this. Thank God, it is derived. So this is the equation you are getting as in place of changing gradient descent of change in delta W. So this is your equation. So guys, I hope you understand this long lengthy mathematical equation, and this is the final equation, and that's why I am directly written this. First I will calculate the y prediction from the sigmoid function, and I will passing this. Same for the grade B. Only the last part is be not available, and this is your final part. So this is the two equation is derived. Clear, Hemant? Himanshu, I guess. Hemant, I guess, whatever the person who asked this question. Clear? So in free of time, you can be understand this mathematical. And now this part is clear. Now second, the last for the prediction. So I generally pass a input of array, multiple inputs, and you will using this prediction value. And for every input, your prediction this, and you are appending your prediction in this list, and it is returning. This is simple. Okay. So now till this point, everything is clear. If you are facing any error, any difficulty, please let me know. But I will try to explain everything till this point. Clear, everyone? Till now. So let's start the training, and this is a very crucial part. So now I am going to use one more approach, and it is called a split the data set. A split the data set. Suppose in the real world, in the real machine learning project, suppose you have like 100 rows or 1000 rows are there as a data set. So generally we split the data set in two parts. 70% go for the training part and 30% go for the testing part. I will explain what is the meaning of testing. Training means you have to train the model to getting the value of W and B after certain number of epoch, and 30% check just this data is right or not, this prediction is training is right or not. So this is simple to splitting the data set, because we have already a function. This is a function train trace split. It is a function to splitting the data set very easily. Right now, if you see like print, you have to run the entire cell one by one, because okay, see right now when you run this cell, you see what your data shape is this, and 1000 row data is available here. Same for the output data. And now I will show you how to split the data set, and after the splitting the data set you will get different type of row for training and different type of row for the testing. Now, so I am going to write train test split. In this split function you need two things. One thing is your data and second your labels. Okay, and third random state. Basically, why I am using random state? Sometimes what is happening? Suppose you have to split the data set and you are getting a set of value, but you next time you split the data set, you will get different set of value. So that's why I am using a random value which is control this split part. Means every time we are going the same value again and again. That's why I am using this random state. This is optional. And the third, okay, and this function will split the data set in two parts, and it is written a tuple containing four values: xtrain, xtest, ytrain and ytest. Okay, and this. Now I am going to run this cell, and when you see xtrain dot shape, and you see the shape is changed. There is 750 rows for the training. Now it's saying test for the, it is returning 250. So by this way you have to split the data set. Now I am going to start the training. First, this is a logistic regression, so let me copy this and I am going to initialize this is an object, and I am going to assign a value log race. Okay, this is a logistic regression. Okay, now let me run this. If everything is okay, it's not returning any error. Now I am calling this function, fit function. This fit function, and fit function needs multiple argument: input, output, number of epoch and the learning rate. By default these two values set for 10 and 0.5. If you ignore this, it's okay, otherwise you have to pass. So now I am going to call log race dot fit. Just one second. Okay, log fit, and passing xtrain input and ytrain output. Clear? Second, you set to be epoch. This time I am using 1000 epochs. 1000 number of times I am going to update the value of W. And learning rate I am supposed to be 0.5 is okay. So after this you will get, your training will start. But I want to show some graph after the training end. So I am adding using the matplotlib here. So matplotlib, so I am going to write plt, just one second, plt dot plot this data, and plot I am going to loss. This loss I am going to plot, and I am going to add plt dot xlabel label and pass. In x-axis I am going to use epoch, and plt dot y label I am going to use mean square error, and I want to show this graph at the end of the training. Now make sure this function should be outer part of this for loop, otherwise it will repeat this function again and again. Now let me run this code one more time, otherwise this code will be not executed and everything is set. Now I am going to run this. And now we start the training. After training start, you see some progress is this, and this progress is so only because of TQDM. Otherwise is this progress by no so. So that's why you are learning machine learning, we see this progress. Maybe sometime your progress is too slow and we have to wait for some hours sometimes. So that's why we have to do that. And you see after certain number of time you have this loss graph. I think the loss graph is not like the right graph this time I'm getting. So let me see if everything is right. uh, it is starting from 0.56 and is go to 0.64. Okay, let me see the data set. Generally the loss function should be decreases, so loss is append. Append means like adding the last, adding the data in the last. And everything is right. Let me check this. uh, I don't know. Let me see this decrement part. Run it once again. Okay, what is happening in this point? Just one second. Generally this graph should be looks like this, because after certain number of epochs your graph decreasing like this, but it's, it is so totally showing in the reverse order. Oh, don't worry, let me check the code. Maybe I am reverting something in my code. Just once again. Just one second, everyone. It will not take too much time, don't worry about it. Y prediction minus y predict. Okay, it is supposed to be this. Maybe I will use some negative positive, and that's why it is showing like this. It is happening sometimes, don't worry about it. In when you drive my question you can get the value maybe. So run it. Run it again, change to be 1000. Run it. Yeah. So this is something understandable, that my equation loss equation is starting from 0.6 and is go to the equation loss value 0.025. Mean after certain number of epoch your loss value will be decreasing. Okay, and it is the right thing. Mean after certain number of training you see if you talk, if you taking the 1000 epoch and you will get this value like very good value like this. But suppose you are changing the value of this, let me run it again to 100 values, and you see the epochs will not go to be the loss function is not decreasing too much. It's starting for 0.42 but it is still only go to the 0.035. But if you're changing the value like 500 or 600, so you see the loss value will be decreased very less number in a less. And this process is called the training, and you see the value is very less 0.05. Suppose I'm changing the value like 2000 and 3000, so that time is good. Maybe right now you only see 0.026, means 0.026 value is getting after the 500 epochs. Maybe I'm not telling this model is good or not. So I will use the finding the accuracy. I will finding the accuracy to getting the right value. Okay, so accuracy will be getting like this. So I'm going to be use some code, like this code is not, this code is, if you're not understanding this code don't worry about it, because this is a Python thing. Because this type of code will not repeat it again, because we are using the custom data. We are using the custom data, that's why we have to be handle this. But now I'm going to use y this function is going to be predict the value, and I'm passing the all the test data. Okay, and because this is logistic regression, your value is not fixed 0 or 1, so we have to be use a code here, y pred binary value, binary test value, and this is getting by like this: if y pred test value is greater than 0.5. This is simple, this is a numpy approach. So just 1 second, let me read this, let me print this first, otherwise you will not understand what is happening. Okay, so see, you are getting some value like 0.03, 0.8 and something like that. This is some value like this. So I will change this value as a integer format. So you have to write y pred binary test, and we have to write y pred. Guys, don't worry if you're not understanding this code. It's not worry, because this type of code is writing from my way, because we are using some library to handle this. So only for understanding I will writing this code. So I am telling this: if the value is greater than 0.5, so let me print this first. What is output in this case? So false means this is a 0.5 greater than, and this is true, and I will convert this value as type of int, as type of int. So this value will convert it to a boolean value, 0, 1 and so on, something like that. Okay, and one more argument is adding here. I don't know why I'm adding this. This is called rebel. Let me check this, why am I doing this. Okay, actually this is the like adding, it is changing the dimension to a single dimension, and it is like this: 0, 1, 0, 1, 0, 1. So we are going to compare this value, to the actual value. This is the all the prediction value for this data set. So now I'm going to compare this value to the actual value, and you have to write accuracy, and this accuracy will be calculating using the scalar accuracy function. You have to write accuracy score, and you have to pass your prediction value, y pred binary test, and your actual value, y test. Okay, and now we are going to be print the accuracy with this accuracy. If everything is right, let me run this. There's something went wrong. Why this is not defined? It should be. Oh, sorry, the spell mistake. Anyway, you see 704 means it is somehow between the 70%. Means your model is 70% giving the right answer. Okay, it is not good model, but guys, because your data set is too complex, this data set is too complex. Sorry, where is the data set? This data set is too complex for this model. That's why it is showing this type of thing. So now I'm going to change the some value. Now I'm going to change this value. Just copy this stuff. Okay. I'm changing the center to. Okay, so let's see after the for easy for like a simple data set, this model return very high accuracy. So I'm going to show the graph that you understand what is inside the data. So this time this data set is this. It is less complex because if your regressive model, if you have creating a regression for this data set, so you can be differentiate like this. So maybe this part is red, this part is green, but you see the sum part is not giving the right answer for according to this model. But if your data set had like this simple data set, so this time you are getting the accuracy is very easy. Just pass simple classifier, and that classifier is good. This is red, this is green. So now let's see how this for this data set my model is working or not. So logistic regression is cool, everything is cool. Now I am going to be copy this stuff, split the data set. This time I'm correct my spelling. Now let me calculate this, calling this logistic regression, and I'm copy this part again, and this time only using the 500 epochs. Okay, and after certain number of epochs, see what is happening. See, it is less than 0.01. And also, if you are going to compare this, and printing the accuracy, so this time you have to use test. So see this time how the accuracy will change. This time your accuracy is 92%. So as a machine learning engineer, you not only focus on the model and the training, okay, you also focus on the data set. If you see this tab, there are two types of data you are facing. This is your data. This is data is a complex data for what? For logistic regression. I mean, logistic regression is not capable to solve this equation, solve this problem. But logistic regression is capable to solve this type of problem. Okay. But what happens? Suppose this type of data set is available, like this data set. So if you are going with this data set, logistic regression is completely fair. Maybe the accuracy will be like 30%. Okay, and this time your accuracy is getting 92%. You can never say that this model is best model. So this model is best for this data set, that model is best for that data set. Okay, so in the upcoming classes I will show you some different type of model. Not every time I am going to code writing the coding in scratch. I am going to write using some library, but I will explain you why other model is best over the logistic regression, why the logistic regression is good for some model. So you have to understand this thing also. Okay, and tomorrow with upcoming classes I am going to explain that use this model for this data set, use that model for that data set, and so on. Okay, not only the data set, not only the training part, but also I'll show you some different type of things, different type of input. Right now you're seeing that your model, if you're talking about this model scratch Python code, I'm using this mean square error. Why I'm using the mean square error? I have to use some different type of optimization. Okay, so I'm going to explain this part is also that sometimes you have to use cross entropy laws, mean square laws. According to data set, according to the problem, you have to choose the mid functionality in the training. So this part is the machine learning. Machine learning is not only the mathematics. Machine learning is not only the like understanding the training part. Machine learning is not only the part of the understanding the Python and so on. We have to fill the data. You have to understand the flow. Okay, that's why I'm explaining the logistic regression by the Scratch Python code. Okay, this part is totally say that you have to understand what is happening in this training, because in the upcoming class you are using the library like sklar or tensorflow or maybe the pytorch. That time you are not going to write this code like in scratch everywhere. Even if you are joining some company, you are not going to write the every line of code scratch. You have to use library. But what type of argument you have to use on that library, you have to understand that. Guys, I'm saying lots of things, but are you understanding what I'm talking about? Yes or no? हेलो, बहुत बोल दिया, तुम लोग कुछ बोलो. हेलो हेलो हेलो. Any question in your mind? A top lot. But yeah, Scratch Python code for a machine learning is in, and I guess I explain every term. I also explain what is happening in the different data set and so on. And you see the loss percentage decreases. Okay? And in the upcoming classes, I'm using other model, but that model I'm going to use by using the sum library. Okay? So if you have some question in your mind, please let me know. And I will share this code with you. Just me. Guys, are you understanding what is happening in this collab sheet? Yes or no? At least say yes or no. If you don't understand, I will repeat it again. Don't worry about it. This is my duty. Tell me, हिमांशु, आकांक्षा, शैलजा और कौन पूछता था? मल्होत्रा, कौन मल्होत्रा है? गरिमा मल्होत्रा. Everything is clear ना? Sir, image will also be covering the recognition project. Yeah, I will cover. Don't worry. I guess I am teaching machine learning is very in a good way because I get so many good feedback in my recent years. So, and I meet multiple trainer in, and I know how I am teaching well. So I try to be explain this very difficult part very easily. I guess if you understanding this part, it's very good things for me. And in the upcoming class, I will use some other type of library like sklearn or TensorFlow for explaining the machine learning model. Okay. So if you have any more question, you can ask. Otherwise, I will log off and will share this video with the Edu-Vitae. They will provide the videos as soon as possible. Okay. So I'm going to stop this recording. Oh, perceptron just like a name of the function, Garima. This function actually I explained this. Now this is the function is returning this dot product of x and self. Actually, this part is already explained in my previous classes. I guess you have didn't append this in my previous class. Okay, anyway, I will explain this part again in my upcoming class because this perceptron comes again and again in my deep learning class. In after the next class, your deep learning class will be started. So where I explain this perceptron multiple times. Don't worry about it. And please understand this code. Go and try to understand every line of code and see what is happening. Okay. Anyway, any more question? So we have to say bye and we'll meet again on the same time on the Wednesday, not same time. Maybe your class time will change by the 7 p.m. and I will share this thing on Google Classroom up by the tomorrow evening.